Okay, move out.
The early American citizen soldiers' weapons were pitifully inadequate by today's standards. His supply of powder and lead was equally limited. At the beginning of the Revolutionary War, the colonies fought for freedom with whatever shot and powder they could scrape together. But if it were going to survive, our infant nation could no longer depend upon small hand tools and forges. It needed a dependable armament source. Even after the revolution was won, the need for an adequate source of armament remained. One reason was simple growing pains. The nation was rapidly expanding westward, and only with sure firepower could the frontier be rolled back. The other reason was defense. The young nation's integrity was imperiled time and time again, both from within and from without. As early as the mid-19th century, the young American Republic could feel secure in her ability to arm herself, for foundries and powder mills had sprung up throughout the country. Like the nation itself, they grew until they became the producers of the seemingly limitless supply of armaments devoured by World War II. The mini ball, flintlock, and powder horn, like this well-used powder tester, were the very best available in their day. Times have changed, but the need for up-to-date, dependable firepower has remained the same. Today's armament is so complex that there's simply no room for confusion or uncertainty. This is the story of the streamlined and centralized system that keeps the Army's weapons combat ready, the story of the Army Munitions Command. The Munitions Command has its headquarters near Dover, New Jersey at Picatinny Arsenal. It provides the Army with firepower for all its weapons systems. The task is staggering. It involves keeping firm control of 4,400 different products, and those are only the end products. Secondary items run to 44,000. Picatinny Arsenal is the Army's main research and engineering center for both nuclear and conventional munitions. Picatinny has lived up to its responsibilities, and that hasn't always been easy. When an unprepared United States entered World War II, there was no other plant in America that could produce anything larger than small arms ammunition. Picatinny had a twofold job. It had to provide private industry with the technical know-how for the desperate fight ahead, while it was filling the production gap by itself. The arsenal turned out countless millions of munitions items, and at the same time, trained thousands of workers in highly specialized skills. But that was years ago, an atomic age ago. Today, Picatinny, like all elements of the Munitions Command, is concerned not with the accomplishments of yesterday, but with the challenges of tomorrow. Challenges that the Arsenal's 7,000 engineers, scientists, and skilled workers have always been determined to meet. Back in 1953, a successful test of a new 280mm shell opened a new era, the era of atomic artillery. But even with nuclear might, we still need conventional weapons. Research, development, and exploration. These bring about enormous improvements in existing weapons, as well as new ideas to keep pace with the future. Streamlining projectiles and redistributing their weight cuts down on aerodynamic drag. With a hollow base, there's more room for the propellant. Ballistic studies like this have led to range increases of 30%. Another idea for increasing range is to put a rocket motor in the base of the projectile. The motor ignites after the initial gun thrust loses its kick. Research and development have also heightened the effectiveness of munitions. Fragmentation, for example, has increased by 70% as a result of new materials. Totally new items have appeared, such as this anti-personnel mine, or this new anti-tank mine. Research in many areas contributed to their development. Picatinny has perfected high-explosive anti-tank ammunition to the point where it will now stop any known enemy armor, literally melting a hole through steel. Here's something else that was developed and tested at Picatinny: cartridge cases that burn up in the gun when they're fired. This promises huge savings in manufacturing costs because the cases are made from more plentiful materials. They'll reduce noxious fumes inside tanks and also eliminate the backbreaking job of hauling away spent cartridges. Here's a new development that looks like silly putty and behaves like flypaper. It's a plastic demolition charge that you can slap on your target like a Band-Aid. It'll stick to almost any surface. But it works like the deadly explosive that it is, even underwater. You can pile it up in layers to add even more power. There's a built-in safety factor, too. It works only when you want it to. Unless you put a fuse on it, it'll take any amount of punishment without exploding. But put that fuse on, and it's something else. It combines speed, adaptability, and muscle. Other current projects include studies of new concepts in rocket engines, new propellants, and the use of liquid propulsion for artillery projectiles. One of Picatinny's laboratories concentrates on plastics. Here they collect and evaluate information for the entire Defense Department. The result, warheads and gun barrels made of plastic, inexpensive, lightweight, non-corrosive, adaptable. Plastics have provided simple answers to many complex problems. Warheads and propulsion systems are a part of the story, but there's more to modern firepower than that. In the pyrotechnics laboratory at Picatinny, work is being done on space tracking, too. This vacuum chamber tests specially designed photo-flash cartridges to see if they'll be dependable in outer space. They're visible for over 1,000 miles. The idea is for the missile in flight to fire several cartridges, one after the other. Even against a backdrop of natural stars, this trail of flash bulbs will show up quite clearly on a photograph. The result, missile tracking even more accurate than through electronics. Another area that's under study at Picatinny is called weapons vulnerability. One irony of science is that technological advances in one area often cause problems in another. For example, some munitions are fired by electrical energy. That's fine if you've got your finger on the power switch. But a nearby radio transmitter or radar equipment can fire them accidentally or knock them out of commission altogether. Picatinny Arsenal is tackling that problem, a tough one, but no tougher than others it has solved in the past. Located in Philadelphia is Frankford Arsenal. It's been one of the cornerstones of the nation's defense program for over 150 years. In physical size, Frankfurt is small, only 112 acres. But coming in a small package hasn't hampered Frankfurt's achievement. Its 6,000 employees are dedicated to their mission. Although it extends to other areas, that mission deals mainly with small arms ammunition. Almost every round of small caliber ammunition ever fired in our national defense was either produced or developed at Frankfurt. Here's one of the Arsenal's latest developments, a duplex cartridge. Each case holds 2 bullets, the rear one angled to send it on a slightly different path. It may not make a soldier a better marksman, but it will give him more hits. That's because the rear bullets strike in a random pattern a few inches from the front bullets. At Frankfurt, they're applying to small arms the principle of a caseless cartridge that burns up in the rifle. The greatest challenge has been to overcome cook-off or premature firing. There are also extraction problems, but Frankfurt isn't giving up. The obvious advantages of an economical, caseless, lightweight cartridge are enough to keep the staff hard at work on it. These are not American weapons. Frankfurt also runs a center for testing the weapons and ammunition of our NATO allies. Frankfurt's major concern is with small arms, but it often supports the development of larger munitions too. We tend to think of munitions in terms of explosives and gunpowder. There's more to it than that. Take the science of optics, for example. Modern weaponry leans heavily on lenses, reticles, and various complex optical instruments. Today, just about every weapons system in our arsenal relies on optics to sight and center on its targets. And the optical aiming devices work on the same principles as those developed at Frankfurt. This work calls for sophisticated equipment with sophisticated names. Here, an aspheric curve generator for changing the geometry of glass. A precise pantograph that engraves lines on reticles, lines 1/10 the thickness of a human hair. If Frankfurt has machines with delicate skills, it has men with skills that are even more refined. A required tolerance of 1/40th of a light wave leaves the machines behind and the men take over. There aren't many craftsmen whose art is polishing parabolic mirrors. Frankfurt Arsenal has them, as well as the highly specialized equipment they need. This particular study deals with automation to see how it can be applied to manufacturing military optics. This complete optical facility is unique to the Defense Department, and it serves the entire defense establishment. Propellants have uses which aren't really firepower in the destructive sense, and Frankfurt develops them too. This device injects soldiers automatically if they're incapacitated with a remedy for enemy nerve agents. Propellants also inflate life rafts for the Navy, the Air Force, and the astronauts in the Apollo program. Another item activated by a propellant is designed to sever lines and cables. It's part of another device, which may well be the program's most noteworthy achievement, the mechanism that ejects Air Force pilots from crippled jet planes. To get the pilots safely out, more than 30 propellant charges must fire, each one at precisely the right instant. The program has saved more than 3,000 lives with no known failures. Frankford's newest mission is to develop equipment that will automate the maintenance of military vehicles. When it's perfected, this apparatus will spot the defects of the vehicle engine instantaneously. Its forerunner, designed for tank engines, is already in operation. It has eliminated costly teardowns for inspection. The Army has countless items, from gun sights to barometers, in which precise calibration is vital. Also at Frankford is the Army Metrology and Calibration Center. This center at Frankford provides the engineering and technical direction for the Army's entire calibration system. Highly skilled personnel ensure that our weapons will be checked with nothing but completely accurate equipment. There are other special research areas at Frankfurt too. These include metallurgy, corrosion, and lubrication. Powdered metallurgy is an old science. Here it's probed for new applications. Friction welding will someday eliminate the brittleness that results from joining two different metals. Ultrasonics are also being explored, as are overlay welding techniques. Frankfurt is working to reduce corrosion in hydraulic systems, and they're working to develop lubricants that will be more effective in the vacuum and shattering cold of outer space. Radiation chemistry research has produced reactions that would have seemed like magic a few years ago and produced totally new compounds. Frankfurt keeps pace with new ideas and stays ahead of them too. The staff is always ready to accept a challenge, proof that this arsenal, which has served America well for 7 generations, will not fail her in the future. Edgewood Arsenal is another center of munitions activity. Located near Baltimore, Maryland, it was established during World War I. This is the headquarters of a whole complex of activities: research, development, manufacture, and supply. The arsenal's mission takes in just about anything chemical. The complex includes 3 Army installations. It employs nearly 8,000 scientists, engineers, technicians, and craftsmen in many specialized fields. At Edgewood are the research, weapons, and defense development laboratories. These labs are responsible for developing defenses against chemical weapons. You'll find the same tools here that you would in any organic chemistry lab, and a few that you'd find almost nowhere else on Earth. This complicated instrument has a complicated name: a nuclear magnetic resonance spectrometer. Its function to pry into the secrets of the invisible and determine molecular structure. The products of this research and development include protective clothing and masks, guards against fallout or gas. This protective mask is standard issue to the military, and this is its civilian counterpart. It comes in all sizes. The masks are defensive weapons, but the products of chemistry can be offensive and include tactical weapons, a wide variety of smoke, flame, and incendiary munitions. In addition to starting fires, Edgewood also concerns itself with putting them out. This work is on a special project requested by the Air Force and the National Aeronautics and Space Administration. When a rocket fuel meets an oxidizer, it ignites spontaneously. Violent, accidental fires can flare up at any missile site where fuel has spilled. Edgewood is finding ways to control these fires. All of mankind has benefited from the Army's chemical and biological research. a vaccine against anthrax, mustard compounds for the treatment of some cancers, the development of weed killers, insecticides, fungicides, and other agricultural chemicals. But Edgewood Arsenal's main objective is to keep the nation strong. This in turn will help keep it free from enemy attack. The Army Biological Laboratories are located nearby at Fort Detrick, Maryland, the center of the Army's biological research and development program. The research at Fort Detrick is similar to the work at Edgewood, but instead of chemicals, here it deals with biological agents. Working with deadly microorganisms is about as dangerous a business as you can find. This is evident from the safety precautions needed to protect the researchers from accidental infection. In addition to the safety measures you can see, all the laboratories are kept under a partial vacuum. This keeps contaminated air from escaping into the clean areas. All work with infectious material is done in sealed cabinets. We can develop our defenses against biological attack only if we learn everything there is to know about disease-producing organisms. Research such as this has had important applications in medical science, leading to the development of vaccines against many diseases. Other results of this continuous study have included rapid warning devices for biological attack and antidotes for biological agents. Development of a complete defense against possible biological attack is the sole objective at Fort Detrick. Even after munitions are designed, developed, tested, and proved, there's still an enormous problem: producing them and getting them to the soldiers in the field. It means knowing who has what, how long it's been there, what shape it's in, how much of it there is, how much more is needed, and making sure that replacements arrive on time. It adds up to a tough and exacting job. It belongs to the Ammunition Procurement and Supply Agency, known as APSA. APSA is located near Joliet, Illinois. Under its direction is the manufacturing of all conventional large caliber ammunition. It also controls inventory and is the maintenance center for chemical munitions. This agency also provides the Air Force, Navy, and Marines with ammunition, propellants, and explosives. In addition, it loads missile and rocket motors for the Missile Command. These activities first got underway in 1940 when the government began a $3 billion construction program. By 1945, 84 plants had been completed to make all types of munitions. Today, 11 of those plants are active. APSA controls the operations of these active plants and holds a number of others in a state of readiness. All of the plants are operated by private contractors. They may manufacture propellants, explosives, shell and cartridge cases, or other metal parts, or assemble, load, and pack finished ammunition items. APSA provides the parts and supplies used by these plants, and it gets these too from private industry. All contract bids get the same consideration, whether the bid is from a small, family-owned plant or from one of the largest companies in the nation. All successful bidders must have the resources, equipment, people, and skill to handle the particular job. Before awarding a contract, the agency conducts a careful survey to make sure that the bidder can meet all the requirements. APSA is also responsible for munitions stored in more than 20 Army depots. It has to keep them inventoried and ready to use. And if, for any reason, ammunition becomes obsolete, this agency sees that it's disposed of properly. One way is to destroy it safely by burning. Another way is to process it into some other useful product that the government can resell. But the agency's main objective is to have the right ammunition at the right place at the right time, and enough of it. When a request comes in, it goes to the manager responsible for that particular item. The item managers take immediate action. During an emergency, they may work on an around-the-clock basis. directly with the Materiel Readiness Control Office. Electronic computers lighten the inventory load. No matter what item is needed, this machine will immediately tell you how many there are, where they are, what condition they're in, and to whom they may already have been promised. And as if that weren't enough, it also advises which depot will get it where it's going the fastest. Everything that came before, the research and engineering, were of course indispensable. But it's procurement and supply that actually, physically, places the tools of combat in the hands of the fighting man, whenever and wherever he needs them. To the layman, it's the spectacular blast of an explosive that tells the story of munitions. But to those in the business, the story lies in the painstaking day-to-day tests, the obstacle course that every item must pass before it's given to our fighting men. Can it withstand the force that sends it on its way? Can it take the rigors of shipment? Will it function at temperatures ranging from 65 below zero to far above 100? The story of munitions is the story of test equipment that can X-ray 2 feet of steel, or freeze on film a projectile spinning at 25,000 revolutions per minute to reveal malfunctions. All this is backed up by computer systems that can answer a question in 1 hour that would take 30 technicians with desk calculators a full year. It's the story of one concept applied to different items. The story of cooperation between different agencies working for common goals. A good example is this solid fuel rocket, which produces 47,000 pounds of thrust in 1/2 a second. It can rescue pilots from planes flying at 4 times the speed of sound. The story of firepower is the story of the Munitions Command's daily efforts to do its job and do it well at Picatinny Arsenal, at Frankford Arsenal, at Edgewood, at Fort Detrick, and at Joliet. That job is very simply to keep us ready. This readiness is an embodiment of a concept as old as our nation. For the words of George Washington hold as true today as they did when he wrote them. To be prepared for war is one of the most effectual means of preserving the peace.